All right, so if you've been building anything with AI, you know that the real fun begins when you go beyond just a simple prompt and response. We all want to create systems that can actually tackle complex, multi-step jobs. But how do you do that? How do you get a bunch of AIs to work together like a well-oiled machine? Well, today, we're going to unpack the design patterns you absolutely need to know to build powerful AI agents. And this is the million-dollar question, isn't it? We need our AI systems to be reliable, we need them to be predictable. But the second you ask an AI to do more than one thing in a row, things can get, well, messy. So how do we impose some order? How do we build a structure that doesn't fall apart when things get complicated? To make all this super clear, we're going to stick with one running example for this whole explainer, planning a trip to San Francisco. We're going to throw this challenge at each design pattern, and we'll see exactly where they shine and where they struggle. Let's start with the most basic one. First up, we've got this single agent. You can think of this as your all-in-one assistant. You basically give it a task, hand it a few tools, and then you kind of just hope for the best. So how does this actually work? Well, it's all about one big, comprehensive prompt. You pack everything in there, the instructions, the tools it can use, the whole shebang. And from that point on, the agent is flying solo. It has to rely completely on its own internal logic to figure out what to do next. And you know what? For a simple request, this can work surprisingly well. You ask it to plan a trip, and boom, it starts using its tools, grabbing info, and putting a plan together. It really feels like it's thinking on its feet. But what happens when we add a little twist? And this is where the cracks start to show. Let's say we get more specific. We ask it to find late-night sushi, and then find the fastest way to get there. Because the AI is non-deterministic, there's just no guarantee it will follow that order. It might find the sushi but totally forget about the directions, or do them in the wrong order. This lack of control, that's its biggest weakness. So, you're looking at a classic trade-off here. The single agent is super simple to set up, and it's flexible, which is awesome for basic stuff. But the more complex the task gets, the more unreliable it becomes. You just can't control the flow. We need a better way to enforce an order of operations. So if the single agent is our unpredictable generalist, our next pattern is the complete opposite. Meet the sequential agent. Think of it as an AI assembly line. It's all about structure, order, and most importantly, control. So instead of one agent juggling everything, now we have two specialists. Agent number one, the food finder, has one job and one job only. Find that late-night sushi. Once it finds a restaurant, its output, the name of that restaurant, becomes the direct input for agent number two, the transportation agent. Then and only then does the second agent figure out the fastest route. It's a clean, totally predictable handoff. Now you might be wondering how they actually make that handoff. Well, that's where this crucial concept of a shared session state comes in. The easiest way to think about it is like a shared digital scratchpad. It's basically short-term memory for the whole system. The first agent writes its results onto the scratchpad, and the next agent comes along and reads it. That's the glue holding our assembly line together. The upside here is massive. We get a huge amount of control and reliability. The system does exactly what we tell it to every single time. But the downside is just as big. It's totally rigid. This assembly line can't adapt on the fly. And just as important, it can be really slow, especially if you have tasks that could have been done at the same time. Right. So what if the tasks can happen at the same time? Well, that's where our third pattern, the parallel agent, comes into play. We're moving away from that linear assembly line and towards a whole team of specialists all working at once. Let's make our San Francisco trip a bit more ambitious. This time, we want to find a museum, a concert, and a restaurant. Now, think about it for a second. These three tasks are completely independent, right? Finding a museum has absolutely zero impact on finding a concert, so why on earth would we do them one by one? Here's how the parallel approach works. We deploy three specialized agents, a museum finder, a concert finder, and a restaurant finder. And we let them run all at the same time. They're all working in parallel, writing their findings to that shared scratchpad. But then, and this is the critical part, a final aggregator agent kicks in at the end. Its job is to look at all those separate results and combine them into one single coherent trip plan. The biggest advantage here is speed. I mean, we are talking about a massive reduction in the time it takes to get an answer. It's incredibly fast and efficient. The catch? Well, it can have a higher upfront cost because you're running multiple agents at once. And you absolutely need that final aggregator step, which does add a bit of complexity to your design. Okay, so
We've looked at the single agent, the assembly line, and the team of specialists. So which one should you actually use? Well, there's no single best answer. It's all about picking the right tool for the job you're trying to do.
This table really lays it all out pretty clearly. Look, if your main goal is simplicity for a flexible task, the single agent is your best friend. But notice how it scores low on control. If you need high control and reliability for a structured process, you have to go with a sequential agent, even though it's slower. And finally, if speed is everything and your tasks are independent, the parallel agent is the clear winner. You just have to accept that it's more complex to build. It's always this push and pull between simplicity, control, and speed. And honestly, these three patterns are really just the beginning. They are the fundamental building blocks, but the rabbit hole goes way deeper. For really dynamic problems, you can start exploring advanced patterns like agents that work in loops to correct their own mistakes, agents that actually critique each other's work, and even manager agents called orchestrators that decide which agent to send a task to next. And all of this leaves us with a really big final question. As we move from just writing prompts for a single AI to building these sophisticated teams of agents, our role as developers is changing in a fundamental way. We're not just prompt engineers anymore, we're architects of entire systems. So as AI agents become the new workforce, what does it really mean for us